So to get more information on this topic, I encourage you to look up creation.com/human chromosome 2, and you can get more information there. Now, the evolutionists claim, let's set this up so we all understand what we're talking about. There's chromosome 2 fusion model. Here's the evolutionist explanation. The theory is that at some point, 2 ape chromosomes fuse to make a single human one. Why do we think this? Because when we look at human DNA, chromosome 2 looks just like 2 ape chromosomes stuck together.
Right.
Okay, so
this is their claim.
It looks just like.
Okay. Here's the evidence.
Chromosomes.
Right? Evidence that human chromosome 2 looks just like 2 chimp chromosomes stuck together, and that the evidence that human chromosome 2 has 2 centromeres. So if we look at the diagram here, we see at the end capping, we'll say, of chromosomes have these sequences called telomeres, repeating sequences of DNA letters. Okay, and then where the bits bunch together, that's the centromere. You can see the diagram up here. So if these two ape chromosomes fuse together, we should see these fusion sites where they came together, and there should be evidence that it has 2 centromeres.
Okay, pretty straightforward so far.
Yeah, at least had it in the past. Okay, so they're coming together here. You've got your fusion site. Okay, these repeating telomeres sites, right, is what we should see. Now, the DNA letters, they're complementary. Okay, so you can see it in one direction it would be TTA, GGG, and in the opposite direction it would be CCC, TAA, because the chemical letters of DNA, C bonds with G and A bonds with T, etc.
Yep.
Okay, so just, I don't want to get bogged down too much here, but we need to understand what the argument is. Okay. Now, at the fusion site, there should be many of these telomere repeats because, but the problem is they don't have many. But anyway, a normal human telomere would have between 1,667 to 2,500 of these TTA GGG repeats. At the site, there's less than 35.
Wow, so that doesn't seem to fit the story of fusion at all, telomere fusion at all.
At all. And to the right of the site, there's less than 150 of the complementary CCC-TAA sequences.
Okay, so again, this doesn't fit with this fusion notion.
Not at all, because if there were supposed to be, let's say 50,000 of these repeating sequences, the percentage that you have is very, very small. Right? And even evolutionists that have studied this, such as this fellow, said if the fusion site occurred within the telomere repeat arrays less than 6 million years ago, why are the arrays at the fusion site so degenerate? So my point is that evolutionists will say, yeah, but degeneration occurred, mutations occurred. But what I'm saying is that if you look into the argument, the evolutionists themselves say that within this time frame of 6 million years, there should not have been that much degeneration. You should still see a massive amount of evidence for these telomere sites.
Okay, so they're actually admitting huge differences.
That's right.
In the telomeres.
Percentage-wise, it's amazing the amount of difference. Now, another problem is that to date, no functional protein coding genes have been found within the telomere sites of normal humans. However, in this supposed fusion region in this chromosome 2, there have been 24 potentially functional genes and 16 pseudogenes found within the 30,000 DNA letter region where these things have supposedly fused together. So there's a lot of functionally useful information.
Okay, which telomeres normally don't have.
Which they don't have. And within that, again, 6 million year time span, even evolutionists are just puzzled. They say, well, how could there possibly be this much useful information just randomly generate within that?
Okay, so they're questioning their own notion.
Exactly.
So if we look at the telomeres, now what about the centromeres?
Well, there should be evidence that there are 2 centromeres, or used to be 2 centromeres, right?
Sure, yeah.
But what they admit is that it should have left 2 centromeres, but there is only 1 now. So the evolutionists are admitting that there's only 1 now, and the reason why they said that there were centromeres here, and the evidence for it, is that every human and great ape chromosome centromere contains a highly variable DNA sequence that's repeated over and over again. It's called the alphoid sequence. It's a 171 base pair sequence that are in centromeres. And so they say, well, we discover these alphoid sequences where we think the centromeres are. But the problem is alphoid sequences aren't limited just to centromeres. if they were to use that argument, you'd have to think that there were, old centromeres all over the human genome. So it's not a really good argument. And the other thing is the centromere that is there now is in a totally different place than the two centromeres would have been. So they have to think that two degenerated and one popped into place.
So you've got different telomeres and different centromeres. So why are they talking about the similarity? It seems like the data is speaking very loudly against those being fused.
Exactly.